All right, everyone, I hope you're doing well. This is lecture 5 in learning how to code with R. If you're coming just straight from the last video, great. We're going to get right into it, picking up where we left off. If not, hopefully you have all this code. If you've watched the other videos, you should. And yeah, let's get into it. So, as I said in the last video, we're going to be doing scatter plots and correlation. So, first off, let's start with scatter plots. Scatter plots are just another way of graphing. And a scatter plot is probably what you might think of when you just think of a normal, like, graph. It's like a bunch of different points. One point height is for the y-axis, one point is for the x-axis, and you choose both of those. So we're going to do graphing scatter plots. And what I want you to do is actually, I want you to copy and paste the first one we did for the histograms, because I want you to be able to see just how similar these are. And they're not the exact same, but they pretty much follow the same pattern. So we're not going to be graphing histogram anymore. So we're going to keep the geom, but we're going to remove histogram and replace it with point. That's the function for scatter plots using ggplot. Then for our x, we're going to keep 3 pointers. And for our y, we can really do anything. We're actually going to get rid of bins here because we don't need a bin. We'll put a comma right here. Y equals, let's think. If we're graphing 3 pointers, maybe we'll graph points. That could be interesting. Yeah, let's graph points on the y. So y equals, what do we have for points? PTS. No letters, so you don't need to put anything around them. And what does it say the issue is here? Aha, no parenthesis. So now you should be good to go, and you can go ahead and run that. And now we have our scatter plots. So I'm actually gonna make this much larger for now, just so we can kind of break it down. So we have points here, 3 pointers here, and this is 3 pointers made, not attempted. So our first player, this is Damian Lillard, as I think we went over in the last video. And Damian Lillard, you could see, averaged just above 30 points. Looks like probably 31, maybe like 32 and a half or something like that on 5 3-pointers. And he is up here in the top right. I think this is Luka. We have Steph right here. I don't remember exactly what the time frame is of this. I think it was a whole season, but it might also be half a season. Might be from a few years ago. And we have everyone else just kind of grouped in here. So now we're going to get into the second part of this, which is correlation. And let me actually check. Just want to see. Yeah, you can see Damian Lillard over this time averaged 31.3 points a game. And Luka, who it looks like had the highest, averaged 33.9. But then over here, you can see right below him, with 33 was Embiid, who made, I guess, 2.2 3-pointers a game. Okay, so now correlation. Correlation just goes hand in hand with scatter plots. Scatter plots is just how you visualize it. And correlation basically shows you, okay, so I have my 3-pointers made, and I have my points. What is that relationship? And not only what is that relationship, but how tightly related are they? That's the main question. So, finding correlation. And I'm just gonna give you the code for it first, and then we'll break it down. So the code is just core, C-O-R, and then you give it the data set, then you do a $, then you do the first statistic, which is 3 pointers, 3p in our case, then you comma, then you give it the data set again, then you $, again, then you give it, I think, points, right? PTS. And that's it. It's that easy. So correlation is on a scale of, I think, -1 to 1, if I remember correctly. If it's -1 or 1, that means it is perfectly correlated. Almost think of it like a slope. If all of these points were in a directly straight line, perfectly linear all the way through, you would have a perfect correlation of 1. Or if we had it graphed for whatever reason like this, that'd be a perfect correlation of -1. you could see here, the more three-pointers made, generally the higher, but it's not perfect. So we might see a correlation here of like 0.6 something, maybe. And that's still, I mean, you can clearly see the more three-pointers made a game, the more you average. And that's generally just like true. I mean, think about it. If you're making three-pointers a game, you're already at 9 points, and then who knows how many free throws or 2-point buckets you'll make. So let's see. Oh, I didn't put 3-pointers. Correlation of 0.29. Okay, that's a lot lower than I thought. But that basically means that there is definitely a correlation there, because as you can see it here, it's getting, when it gets higher, typically the points get higher. But now that I'm looking at it more, you can see here, like, these people make no three-pointers really, or actually 2 3-pointers a game isn't that bad, but very few 3-pointers a game compared to over here, but they have a similar point total. So let me actually show you something that will have a much higher correlation. Let us do the correlation between, why can't I delete that? Okay, we're going to just copy and paste it, and we're going to replace points with our 3-pointers attempted. And as you can imagine, that is going to be really tightly correlated. The amount of 3-pointers you attempt versus how many you make. Let's see it. Yeah, correlation of 0.94. And let's actually just, we may as well plot it, right? Why not? Kind of free balling here, but it's fine. Copy and paste the code. Just replace that one thing. And now you can see it's a straight line. I mean, and that's what you'd expect, right? If you're shooting 4 3-pointers a game, you're not going to make 5. That's not possible. So if you're shooting, everyone shoots probably between, or we could actually see. Miles Turner shot 45% from 3. CJ McCollum shot 25%. And that's the entirety of the range. And you could see it very quickly pushes towards the middle, and everyone's in the 30s. So everyone is just going to be in this line. And that's just an example of a high correlation. And here you could see, here's a correlation, but my guess was off before. This is a lot smaller than it actually is. So I hope that kind of makes sense. We're going to move on to some more graphing things in the next one. I think regression might be our next topic for coding. Yeah, and if you found this video helpful, let us know. We'd appreciate the feedback. And have a great rest of your day.